Now let's look at some special functions in R. Probably a more accurate way of saying this is now let's look at some special ways that we can write functions in R. Special functions have a different form than the usual function name and arguments format. Base R has quite a few special functions, such as arithmetic operators. If you think about it, when you use the plus sign, that is doing a function. It's summing numbers together. But it doesn't look like a normal function, it's just a plus sign. Users can also create special functions. Types of special functions include infix operators and replacement functions, and that's what I'm going to focus on here. Most functions in R are prefix operators, meaning that the function name precedes the arguments. But we can create infix operators by enclosing it in two % signs. Here I'm going to create an infix operator that pastes two strings together. So note what I have. I have backticks, and then within those, two % signs and a plus sign. I'm going to assign to that the function that has two arguments, a, b, and then what are we going to do with those arguments? We're going to take and paste them together, put them in a new string, and we're going to return that new string. Now remember, when you paste and don't say what the separator argument is, it will automatically use a space. So this is going to create a new string that has A space B. Whatever's in A space whatever's in B, and that's what it will return. This looks exactly like every function we've been doing except for one thing. Right here, the way we're naming the function. That's all that's different about an infix function is how we name it. But then once we've defined it, now look what happens when we use it between two arguments. Here I have a string, Abraham, which is going to be the argument that is formally defined as A. This is going to be the actual argument. And then Lincoln is going to be sent to the formal B argument, Lincoln being the actual argument. And what's different here is we have the function name in between those instead of as a prefix. So thus the term infix, as opposed to before, it's within. I didn't define the function. Let me try that again. All right. Now if we look at our console window, we see Abraham Lincoln is what was returned by that function. Now if you want, you can use infix functions just like prefix functions. So here I'm putting Abraham and Lincoln in parentheses, and here is the function name. Note that if I'm going to do it this way, I have to put the function name in backticks, where when I use it as an infix, I did not need those. So we needed those when we define the function. We don't need those when we use them for their intended purpose as an infix function. We do need the backticks when we use it as a prefix function. You can even use built-in infix functions this way. We can, of course, in the console window, I'll type 2 times 4, and the infix operator, the infix function, is times. But if I put it in backticks, I can put it out in front and put the arguments in parentheses, and we do the same thing. Replacement functions are used to modify a value within an object. Here's a function to replace the first two values of a vector with some number that we hand to the function. Now, I don't know why we need this other than to demonstrate replacement functions. So here I'm going to create a replacement function. I'm going to call it change first second, and I'm going to define it like this. Note that I'm using the backticks. Let me go ahead and run that. In my environment now, you see that change first function is now, or first second is now available to us, change first second. Let's create a vector and then we'll call the function. So here's a vector that is going to be 50 through 60. And what this function does is it takes our vector and then it takes some value and then it replaces the first two numbers in the vector with that value. That's why I'm calling it change first second. It's like change first and second values. So let's call change first second with 20. And then we'll see in the vector that our 50 and 51 were changed to 20 and 20. So we can create replacement functions just like regular functions and then use them to the left of the assignment operator in order to make a replacement. Remember that everything that happens in R is a function. So what we just learned is when we replace values through subsetting, we're just using a base R replacement function. When I say my vector 1 should be 10, that all I'm doing is using a replacement function that's built into R, just like I used a replacement function that I defined up here on line 374. Infix functions are called with the function symbol between arguments. User-created infix functions are of the form %, the symbol %. Predefined infix functions are two % signs with nothing between them. That's the remainder operator, which provides you the remainder after you do a division, also known as modulus. An asterisk or multiplication within % signs, which is for matrix multiplication. A division within % signs, which is for integer division to give you the whole part of the division, not the remainder. The in within % signs, which is a matching operator. This lets you know whether a value or a vector is within another value or vector. Then the % sign with an O between them, which is the outer product, which has to do with linear algebra and matrix operations, which you do not need to know for this course. And then an X within two % signs, which is for a Kronecker product, which is again for matrix operations and is a generalization of the outer product. Then there are other infix functions that are so special that they were created so they don't even have the % sign around them, but they still work as infix functions. So these are only found in base R. You're welcome to look any of them up. I'm not going to go through the entire list, but I propose that you already know most of these. Replacement functions are used to modify object values. User-created replacement functions are of the form the name of the function and then the assign to operator. Sample predefined replacement functions are attributes and names. Note that what defines a replacement function is this little assignment as part of the name. I didn't spend much time pointing that out here, so let me make sure you see it. Note here the replacement function has that little assignment operator as part of the name. We don't actually use that when we name the function, but when we define it, it has to be part of the name for definitional purposes. So you have used predefined replacement functions like attributes, where you assign, and you didn't need less than and hyphen to be right next to the attributes because that's in definition. You just use the usual assignment operator to create a new attribute or to create a new name. Other replacement functions are the ones we use for vectors and the ones we use for lists, the single brackets and the square brackets.